All right, so for learning target 2, we are going to write a 2-column proof using the algebraic properties. And so the algebraic properties are something that hopefully you're familiar with, at least you've used them in the past. I'm going to quickly just remind your brain of these, and I'm going to show you how to use them in a proof. That's going to be the crucial part to this. So commutative property here is the property that tells us what you see, how you see the problem. So A plus B can be swapped to be B plus A. It works with addition and multiplication. A times B is B times A. The associative property is the grouping, the order in which you do, which is why I have Scooby-Dooby-Doo, the problem. And so you can, a lot of times people associate the associative property with parentheses. Not always the case. Here we're adding the X and the 8, and here we're adding the X and the Y first, but it doesn't matter as far as getting the correct answer. Reflexive property, anything is equal to itself. So I took some twins from TV to show you A is equal to A, 7 is equal to 7, and this property needs to be starred. So go ahead and star this property. Very important. Anything is equal to itself. I know that sounds very silly, but throughout this year, we are going to be using the reflexive property a lot. Let's go to that next page. Symmetric property. You can flip things around the equal sign. So if A is equal to 2x, then 2x is equal to A. So I just did things that are symmetrical here. And you're flipping around the equal sign. Some people think of this as the commutative property, but it's not. You're rewriting the equation with what was on the left is now on the right. Transitive properties like a train. If A is equal to B, B is equal to C, then A is equal to C. So if I'm as old as Cameron Diaz is as old as Eminem, then I'm as old as he is, which we are. We're all the same age. You probably don't know Cameron Diaz. Do you? Oh, very nice. Another math example, if y is 2x, 2x is 5, then y is 5. See that connector? It's acting like a train. Substitution. We can take out an operation and substitute with its answer. 7 plus 15, substituted with 22. 2 times 10, we can substitute with 20. That's substitution. We're taking out, replacing with an equivalent value. Distributive property happens over addition and subtraction. And this one is an example of distributive property. You just multiply in the parentheses. Let's go to properties of equality. The addition property of equality says you can add the same thing to both sides. Subtraction property of equality, you can subtract the same thing from both sides. Multiplication property of equality, you can multiply the same thing on both sides. And division property, you can divide the same thing on both sides. You don't change the value of the equation by doing that to both sides of the equation. Multiplicative identity. What do you multiply by to keep a number's identity? 1. So anytime you multiply by 1, you're not changing the number. Multiplicative inverse is when you take a number times its inverse, like 2 times 1/2 is 1. 3 times 1/3. 4 times 1/4. 5/2 times 2/5. Any number times its inverse. Additive identity property. What do you add to a number to keep its identity? You add 0. So that is the additive identity. We have the additive inverse property, like -2 plus 2. Let's go to the next page. Multiplicative property is 0. Multiplying by 0 gives you 0. Okay, for this slide, what I'd like you to do is to pause the movie, put your properties for each one of these, and when you finish, press play. Okay, now that you have finished it, let's see how you did. Number 1, additive inverse, because you're adding a number's inverse. 2, multiplicative inverse, 2/3 and 3/2 are inverse. 3, multiplicative identity, multiplying by 1 keeps a number's identity. 4, additive inverse, 14 and -14 are inverses. And 5, additive identity, when you add 0, you keep a number's identity. 6, symmetric property. You are reflecting it. So x equals 2 becomes 2 equals x. Symmetric property of equality. 7 is commutative property. You're swapping the a and the 7 in the way that you see the problem. 8, distributive property. 9, reflexive property. Anything is equal to itself. 10, what you would do to both sides is you would subtract 4. And so you're using the subtraction property of equality. Let's go down to this, and I will show you what this is as far as using properties for a proof in geometry. The first thing you need to know about a proof is that you have statements and you have reasons. So you have statements and you have reasons. And on the left are the statements, and in fact, with this, how you would solve this algebraically. And on the right are our reasons. The other thing you need to know is that the first line is what was given. And the last line is what you want to prove. So we're given the first line, which is our reason for having it, and then we want to prove that x is 0. That's the whole point of this. So let's go through each one. To get the reasoning for the second line, we ask ourselves, what do we do to the first line to get to the second line? And you can see that we took the 2 and distributed in. So this is distributive property. Then, what do we do to line 2 to get line 3? And that reasoning goes for line 3. And you can see here that we swapped 2x plus 6 to become 6 plus 2x, commutative property. Then, we're seeing what did we do to line 3 to get to line 4? And you can see right here, 6 plus negative 6 became 0. So that's called the additive inverse. What do we do to line 4 to get to line 5? 0 plus 2x just became 2x. So that's our additive identity. What do we do to line 5 to get to line 6? Well, we took the 2x minus 5x, and that became negative 3x. So that is adding like terms. You could also put combining like terms. What do we do to line 6 to get to line 7? And that reasoning goes over here. And that negative 2 plus 2 became 0. So that's the additive inverse. What do we do to line 7 to get to line 8? Well, we would divide both sides by negative 3. So that's the division property of equality. And that is how we do an algebraic proof. That's what I would like you to do on your homework for this lesson. Thanks for watching the movie.